In section 4.3, we will now define the trigonometric functions in terms of the right triangle. So in the right triangle given, we have angles A, B, and C. The side opposite angle B is B, and the side opposite angle A is A, and of course, the side opposite the right angle, the hypotenuse, is C. So the definitions are as follows. Let's call this theta, angle theta. So by definition, the sine of theta is going to be A divided by C. In other words, A is the length of the opposite side of angle theta. So the length of the opposite side of angle theta divided by C. C, of course, is just the length of the hypotenuse. All right. The cosine of theta is defined to be the adjacent side of theta. The adjacent side is side B divided by the length of the hypotenuse. So we have the cosine of theta is B divided by C. The length of the adjacent side of angle theta divided by the length of the hypotenuse. All right? The tangent of theta is going to be the length of the side opposite angle theta, which is A, divided by the adjacent side of angle theta. The adjacent side is B. So the tangent of theta is defined as A divided by B. And I'll just abbreviate. The length of the adjacent side of angle theta divided by the length of the opposite side of angle theta. The cosecant of theta is defined to be the hypotenuse, C, the length of the hypotenuse, divided by the opposite side of angle theta, which is A, the opposite side of angle theta. So that's C over A, being the length of the hypotenuse divided by the length of the opposite side of angle theta. Secant of theta is defined to be the length of the hypotenuse, which is C, divided by the adjacent side of angle theta, which is B. So that's the length of the hypotenuse divided by the length of the adjacent side of angle theta. And the cotangent of theta is defined to be the adjacent side of angle theta, which is B. So that's B over divided by the length of side A. So that's B over A. So that's the length of the adjacent side divided by the length of the opposite side of angle theta. All right, given the right triangle ABC, Let's find the values of each of the 6 trigonometric functions of theta. All right? So we have A is 3, B is 4. We need C. But since it's a right triangle, we can use the Pythagorean theorem to find C. C squared is equal to A squared plus B squared. We see that A is 3, so that's 3 squared plus B squared. B is 4, so that's 4 squared. And we get what? We get C squared is 9 plus 16. So C squared is equal to 25. And C is the positive square root of 25, which is 5. All right? So referring to the length of each of the sides, we can now use the definitions of the 6 trigonometric functions as defined in terms of a right triangle. All right, so let's begin. We said that the sine of theta is what? The opposite side divided by the length of the hypotenuse. So in our case, sine theta, the side opposite sine theta is 3, and C, the length of the hypotenuse, is 5. So the sine of theta is 3/5. The cosine of theta is defined as the adjacent side divided by the length of the hypotenuse. So in our case, theta, the adjacent side is B, which is 4 divided by the length of the hypotenuse, 4/5. The tangent of theta, is defined to be the opposite side, length of the opposite side divided by the length of the hypotenuse. So in this case, it's going to be 3 divided by 4. The cosecant of theta is defined to be the hypotenuse divided by the length of the opposite side of angle theta. So in this case, we have the length of the hypotenuse 5 divided by the length of the side opposite angle theta is going to be 3. So the cosecant of theta is 5/3. The secant of theta, the secant function is defined to be the length of the hypotenuse divided by the length of the adjacent side of angle theta. So in our triangle, we have 5 divided by the length of the adjacent side, which is 4. And now the cotangent of theta. The cotangent of theta is the adjacent side, the length of the adjacent side divided by the length of the opposite side of angle theta, which in this case is 4 divided by 3. In the next example, we want to find the value of each of the 6 trigonometric functions of theta in the given figure. And we want to express each value in simplified form. So let's see what we have. We have a right triangle ABC. C is 5, A is 1. We need B. We can find B again. It is a right triangle, so we can find B by using the Pythagorean theorem. C squared is equal to A squared plus B squared. C is 5, so this is 5 squared is equal to 1 squared plus B squared. 5 squared is 25. 1 squared, 1 plus B squared. So B squared is 25 minus 1, which is 24. So B is the square root, the positive square root of 24. And we can simplify this. We can simplify the square root of 24. 24 is 4 times 6. So the square root of 4 is 2 times the square root of 6. So that's B. So B is 2 times the square root of 6. All right, now we can find the value of each of the trigonometric functions. So let's begin with the sine of theta. The sine of theta is the opposite over the hypotenuse, so this is going to be 1 over 5. The cosine of theta. Cosine of theta is the adjacent over the hypotenuse. The adjacent side of theta is B, so we have 2 times the square root of 6 divided by 5. The tangent of theta is the opposite side over the adjacent. So the opposite side is A1. The adjacent side is B. So that's 1 divided by B. 1 divided by 2 times the square root of 6. All right? And let's express this in simplest form. So we can rewrite this as, let's multiply by the square root of 6. We have the square root of 6, 2 times the square root of 6 times the square root of 6, which is the square root of 6. 2 times the square root of 6, the square root of 6 is the square root of 36. The square root of 36 is 6, so we have 2 times 6. So the final answer is the square root of 6 over 12. The cosecant. The cosecant of theta. The cosecant is defined to be the hypotenuse over the opposite side of the angle. So in this case, it's going to be 5 divided by 1, which is 5. The secant of theta. The secant of theta is defined to be the hypotenuse divided by the length of the adjacent side of angle theta. So what do we have? We have 5 divided by the length of the adjacent side. B is 2 times the square root of 6. All right, and if we simplify this, this is going to be 5 times the square root of 6 divided by 2 times the square root of 6 times the square root of 6. So we have 5 times the square root of 6. The square root of 6 times the square root of 6 is the square root of 36. The square root of 36 is 6 with 2 times 6. So the final answer is 5 times the square root of 6 divided by 12. And now the cotangent. The cotangent of theta. The cotangent of theta is going to be the adjacent divided by the length of the opposite side. So the adjacent is 2 times the square root of 6 divided by the length of the opposite side, which is 1. So we have 2 times the square root of 6. This is the cotangent of theta. All right, function values for special angles. Special angles such as 45 degrees, 60 degrees, 90 degrees. Well, in the last section, we used the unit circle to find values of the trigonometric functions at pi over 4. Now, to find the values of pi over 4, which is, of course, what? 45 degrees, using now a right triangle. So we construct a right triangle with a 45-degree angle, 45, actually with what? Two 45-degree angles. It's an isosceles, right? It's an isosceles triangle. Two sides are equal. All right, now in this, let's assume that each leg of the triangle has a length of 1. So we need to find the length of the hypotenuse. Let me call it C here. All right, so we can do that by using the Pythagorean theorem again. C squared is equal to 1 squared plus 1 squared. C squared, 1 plus 1 is 2. Taking the positive square root of both sides, we get the square root of 2. So C is the square root of 2. All right, let's look at an example. So in the right triangle, all right, we have 45 degrees, 45 degrees, and we know that the length of the hypotenuse is the square root of 2. Each leg has length 1. All right, so in this example, we want to find the sine of 45 degrees. The sine of 45 degrees, remember sine is what? The opposite side of the angle divided by the length of the hypotenuse. So in our example here, we get 1 divided by the square root of 2. All right, which is the square root of 2 over 2. The cosine of 45 degrees, we define the cosine as the adjacent side divided by the length of the hypotenuse. So we have, again, 1 divided by the square root of 2, which is the square root of 2 over 2. The tangent of 45 degrees, we define the tangent to be the opposite side over the length of the adjacent side. So in our case here, we get what? 1 divided by 1, which is 1. And now the cosecant of 45 degrees. The cosecant is defined as the length of the hypotenuse divided by the length of the opposite side of the angle. So in our case, we have the square root of 2 divided by 1, which is the square root of 2. Okay? And you might, for homework, you might want to find the secant of 45 degrees and the cotangent of 45 degrees. All right? In the last example, we looked at the trigonometric functions of an angle that measures 45 degrees. But there are two other special angles that we also want to be familiar with. And those are 30 degrees, or pi over 6 radians, or 60 degrees of pi over 3 radians. You really should know the exact values of the trigonometric functions of these special angles, 30 degrees and 60 degrees. All right, so let's see how we are going to derive this. So let's draw an equilateral triangle. We have an equilateral triangle. All of the sides are equal. Each angle is 60 degrees. All right, and we're going to assume that each side has a length of 2. Now, half of the equilateral triangle, let's see what happens if we consider half. So I'm going to basically do this. So if I do that, let's see what I have here. All right, so that's going to be 30, 60, all right, and this is 2, half of the base, so this is 1. So we have a 30, 60, 90 degree triangle. 30 degrees, 60, 90 degree triangle. All right? So we need, let's call this H. We need the length of H. All right? So we're going to use the Pythagorean theorem to do that. We're looking at the 30, 60, 90 degree triangle. All right, so we're going to use the Pythagorean theorem. So we have what? 1 squared plus h squared is equal to 2 squared. All right, if we solve this, we get what? 1 plus h squared is equal to 4. H squared is equal to 4 minus 1. H squared is equal to 3. If we take the positive square root, we get h is equal to the square root of 3. So this is the square root of 3. So h is the square root of 3. All right, an example where we find the sine of 60 degrees, the cosine of 60, sine of 30, cosine of 30 degrees, tangent of 30, and the tangent of 60 degrees. And of course, we're going to use what? The 30, 60, 90 degree triangle. So we have all right, and we know what? We know that this is the square root of 3, 1, and this is 2. All righty, so that's a 30, 60, 90 degree triangle. All right, so let's find the sine of 60 degrees. Here is 60 degrees. We define the sine of any angle, theta, to be the opposite over the length of the hypotenuse. So 60 degrees, the side opposite the 60 degree angle, is the square root of 3 divided by the length of the hypotenuse 2. So the sine of 60 degrees is the square root of 3 over 2. The cosine of 60 degrees, we define the cosine to be the adjacent side of the angle theta divided by the length of the hypotenuse. So here's 60 degrees. The adjacent side is 1, and the length of the hypotenuse is 2. So the cosine of 60 degrees is 1/2. The sine of 30 degrees, again, the sine is defined to be the opposite side over the length of the hypotenuse. So we now 30 degrees. The side opposite the 30-degree angle is 1. So we have 1 divided by the length of the hypotenuse, 2. So the sine of 30 degrees is 1/2. The cosine of 30 degrees, again, adjacent side over the length of the hypotenuse. 30 degrees, the side adjacent to the angle 30 degrees is going to be the square root of 3. So we have the square root of 3 divided by 2. And now the tangent of 60 degrees. The tangent of 60 degrees, we define the tangent of an angle theta to be the opposite side of that angle divided by the length of the adjacent side of angle theta. So for 60 degrees, 60, the side opposite the 60-degree angle is the square root of 3 divided by the adjacent side of 60 degrees, which is 1. So the tangent of 60 degrees is the square root of 3. And now the last one, the tangent of 30 degrees. Again, tangent, the opposite side, divided by the length of the adjacent side. But now 30 degrees. 30 degrees. The side opposite the 30 degree is 1. And the length of the adjacent side is the square root of 3. So we have 1 divided by the square root of 3, which is the square root of 3 divided by 3. Trigonometric functions and complements. We recall that two angles are complements if their sum is 90 degrees or pi over 2. So let's say that, so this is theta, so its complement would be what? 90 degrees minus theta. So what we're saying then is that the sine of theta is equal to the cosine of the complement of theta, which is what? 90 degrees minus theta. And we see this to be the case if we look at the figure. The sine of theta is A over C, and the cosine of the complement, is what? The adjacent side, which is A over. So we see that indeed they are the same. So if two angles are complements, the sine of one is equal to the cosine of the other. We say that the sine and cosine are cofunctions of each other. Cofunctions. So sine and cosine are cofunctions. All right, now let's look at an example. All right, in the example, we want to find a cofunction with the same value as the given expression. So in the first example, we have the sine of 46 degrees. So we know that the sine of 46 degrees is equal to the cosine of its complement. So that's the cosine of 90 degrees minus 46 degrees. So that's the cosine of 44 degrees. In the next example, let's find the cofunction for the cotangent of pi over 12. All right, so the cotangent of pi over 12 is going to be what? So the cotangent of pi over 12 is going to be the tangent of its complement. So we write this as, it's in radians, so we have pi over 2 minus pi over 12. So this is the tangent of pi over 2 expressed in terms of 12ths is going to be what? 6 pi over 12 minus pi over 2. What do we have? The tangent of 6 pi over 12 minus pi over 12 is going to be 5 pi over 12. Applications. We now want to consider applications of right triangle trigonometry. In many application problems dealing with right triangle trigonometry, we are confronted with the situation of an angle made with an imaginary horizontal line. Let's see what we mean here. So let's say that we have, all right, the imaginary horizontal line. That's the horizontal line. Okay. So an angle formed by a horizontal line and the line of sight to an object is above the horizontal line is called the angle of elevation. So all right, so here's the horizontal line, and let's say that we have an observer. The observer is located here. All right, let's say it's here. So the line of sight above the line is going to be here. So this is the line of sight above the horizontal line. So the angle formed with the horizontal line and the line of sight, this angle is called the angle of elevation. Angle of elevation. On the other hand, the angle formed by a horizontal line and the line of sight to an object that is below the horizontal line. So below the horizontal, here's the line of sight. All right, and it's below the horizontal line. So the angle formed by the horizontal line and the line of sight is going to be called the angle of depression. Let's look at a couple of examples. Okay, an example. The irregular blue shape in the figure represents a lake. The distance across the lake, A, is unknown. To find this distance, a surveyor took the measurements shown in the figure. What is the distance across the lake? All right. Let's look at the figure. We have a known angle, which is 24 degrees. We don't know A. We have to find A. And now we have to select the appropriate trigonometric function which allows us to use the given data. So we have angle theta, which is 24 degrees. We also have what? Well, we don't know the side opposite the 24 degree angle, but that's the opposite side. We do know the length of the side adjacent to the 24 degree angle. So which trigonometric function is the most appropriate? Well, it is the tangent. All right, so the tangent of 24 degrees is going to be A divided by 750. All right, and so now we can solve for A. We have that if we multiply both sides by 750, we then have A is equal to 750 times the tangent of 24 degrees. So therefore, A is approximately 750. All right, using your calculators, the tangent of 24 degrees is 0.4452. So if we do the multiplication, we get that A is approximately 333.9. So therefore, the distance across the lake is approximately 333.9 yards. So now, a homework problem. So I'd like for you to do this problem for homework. Post any questions to the discussion board. So the first person to post the correct solution to this problem in the discussion board under Chapter 4 questions will be given extra credit. However, it must be posted by April 2nd. Any student can post a question about the problem if he or she does not fully understand how to solve the problem.